So good afternoon. Welcome to this webinar, Linear and Non-Linear Forecasting with Stata. We're just going to go through a few housekeeping slides as we start. So we're using the GoToWebinar software today, and we're going to be talking for about an hour. The webinar will be an hour, so Marianna will be speaking for about 40 minutes, and then there'll be an opportunity for some questions. If you do have questions, just type them into the box on the panel on your right, and your questions will be answered at the end of her presentation. So now I'll just pass straight over to Marianna.
Okay, so we can start. We are going to use Stata 13 today, and the data set that you should have uploaded is the Durlauf and Johnson DTI. The data set is provided by the authors of this famous paper that was published years ago. They used this data set, so the first thing to do is to look into the data set. So you can go in the data editor, and we can see which variables do we have in our data set. So here we have the GDP growth, which will be our dependent variable. Then we have the logarithm of the GDP, the investment, initial investment in GDP, population growth, school, real GDP, so this is expressed in dollars, and literacy. And here we have a column that I added just for the exercise, in which we can see that time range between 1960 and 1983, and data are collected quarterly. So, we are going to open a do file. So perhaps you already know that you can work both here in Stata or opening a do file. That's what I suggest you to do, because you can then save the file and continuously update or just make any change. So the first things to do in Stata is to define the macros. So I will write here macros so you can keep records of this. So the first one will be our dependent variable. As I said, our dependent variable is the GDP growth. The second important thing to say, as we are working with a time series data set, is to define time variable, which is date. You should be able to see here also, okay, here in the label, okay, the name of the variables. And then, as you probably already know, you have to highlight everything you've written and execute the command. And here you can see that everything goes well. We do the same for the second command. So you have defined our variables, and then you can describe the data. The standard command I'm going to use today is describe the Y list and time. So we can get a description of our data here, or at least of the variables we want to focus on. So as you can see, Stata recognize the variable name, okay, the one that we mentioned, and then to have much more information, you can summarize the data. Again, you summarize both the Y list, which represents the dependent variable, and time. And again, execute. Okay. Here you can see that immediately Stata says the number of observations, so the basic statistics, descriptive statistics. We have 96 observations, mean, standard deviation, minimum and maximum. Then another important thing to do in Stata when you are using a time series, as we are doing today, is to set the data, the data as time series. So you are going to tell Stata now, using this command tset, that this dataset is a time series dataset. So tset date, which is the name of our time variable, and execute. And here you can see that the Stata is going to recognize our time variable date. Okay, it is going to tell you that it ranged between 1960 and 1983, and delta is 1 quarter. So as we have seen before, data are collected quarterly, and Stata recognize all these instruction. So now the next things that we can say, that we can see together, is what we can do is to plot the data. Okay, so I assume probably you already know that if you write using after the star, this is not a command, so you can write everything here that could be useful for you even to remember later on what the do file is covering. So to plot the data, we use this command to-way, and we write ts line y east. Okay, here we are going to plot the data, just a few seconds, and Stata will show you our dependent variable here on the vertical axis. So here we can see GDP growth and date quarterly. That's a first important step in when using a time series data, especially when you are going to estimate a linear model as the one we are going to estimate today. Because the first important information is that our data are pretty stationary. And that's very important because it's an important condition to apply the ARIMA model, that is the one we are going to use today. Stationarity in a time series means that mean and variance do not change over time. Clearly, if we, for example, add another kind of data set, let's say the GDP of US from 1920 to 2012, clearly the data would appear in a different way. So we could expect to see a trend, an increasing trend in the GDP. In that case, we have a not stationary variable, and this is something that Stata allow you to handle. So just for your knowledge, in case you have a not stationary variable, you have to tell Stata in the macros that you want to use not the the data as they are in the column GDP growth, but you want to use the difference variable. So you are going to use this command, d dot, and then the name of the variable, so GDP growth. This is just an example, so it does not apply to us because we have, as I said, stationary data. So here we can just for record say that this is for difference variable. Okay. And in the remaining part of the exercise, in case you have not stationary data, you are going to use always this as dependent variable rather than this one. Okay? So as I said, this is not our case, so we have stationary data. And we can formally test for this stationarity. So after having plotted the data, we can test for a decay Fuller our data. Okay, so the decay Fuller test is this simple command, d Fuller y list. And then you can use both drift or trend. We are going to use drift now, regress, and lag, setting 0. Now you execute this file. Oh, regress. Okay, there was a mistake. Back. When Stata does not recognize the command, you are going to say you have always a red error message. Okay, so you can execute the right command. Okay, and what you can see here is the delta dependent variable. And here you have the first lag. So the independent variable is the first lag. You can look at the coefficient and the test statistics, and it's going to tell you that it is significant. So we can reject the null hypothesis that the coefficient is not significantly different from 0. This means that this is a further confirmation that our data are stationary, so we can use GDP growth for the ARIMA model. Next things to do with time series data and linear model forecasting is the Correlogram. So the Correlogram is a graph of the autocorrelation coefficient for various lags of a time series. The command is correlogram y-list. You execute this command, and here you can see the results. Here you have the AC, PAC column. Here we have the number of legs, and here you have the autocorrelation function, the partial autocorrelation, which again confirms that we have stationary data. So you don't have a very strong one component, so and then a slow decay, but data are pretty stationary. So this is a further confirmation that our data are stationary, are the good data for the ARIMA model we are going to test. So we can use the dependent variable GDP growth rather than the d.GDP growth. You can also have the AC, so the AC command for our Y list. And here you get the graph. And the graph again shows you that data are pretty stationary, so the variance move around 0. So we don't detect any increasing or decreasing trend in our data. Similarly, you can do PAC, Y-list. Again, you have a further confirmation that our data are stationary. Now that we have done all the useful check to ensure our data are stationary, so we ensure that we respect this condition for using a linear model for forecasting, we can start to estimate a few ARIMA model. So, ARIMA model. As you probably know, the ARIMA model, so ARIMA means is the integration between the autoregressive and the moving average models. The autoregressive model accounts for the relationship between our Y-list, our dependent variable, and its lag. So the relationship between YT and YT minus 1. While the moving average model accounts for the relationship between YT and its residuals. I means integrated, and actually I account for the difference variable. So in the model we are going to estimate today, we are not specifying any differences because, as I said, we have stationary data. So the command is simply ARIMA and Y-list, ARIMA, and here we can decide the number of of component we want to have in which part of the model. So let's start with the basic one. So 1, 0, 0, which is, I want to tell you, it is an ARIMA, okay, or AR autoregressive 1, okay. 1, as you can see, is the number of components we have here, for the number of lag we have in the autoregressive component, and here we have 1. We can try to estimate this model first. Okay, here we have the results. So here we have the lag in the autoregressive model, but it's not really significant, so we should try something else. Well, we can do many specifications, so let's go for another one. ARIMA, we are going to estimate another model here, so no more autoregressive 1, but ARIMA whitelist, ARIMA, and let's say 1 lag on the autoregressive component, 0 on the differenced, so here we always, in the middle, I mean, we always have 0 as we are not differencing our variable, and 1 lag on the other component. And here you see the number of lags for the autoregressive and the moving average part, and they are both significant actually, so this is a good sign. But we can do even another specification, so ARIMA whitelist, ARIMA 2, for example, 2 lags, 0 difference, and 1 lags in the moving average component. Here we see that the 2 lags actually do not work very well, because here we don't have a good coefficient. So now that we should decide which models is the best for us, we can use both the significance clearly of the coefficients that we have seen here and in the other results. Okay, but we have also another option, or at least we have to consider also another option, which is the check for model fit, AIC and BIC for model fit. So here what we are going to do here is basically to re-estimate these models, not all of them, but clearly you can estimate all of them. But what I suggest is to select those that at least gives you a first sign of significance. So you can concentrate on 2 of them, for example, let's say in the second and the third one. We are going to re-estimate them, and using this command to have start IC to have the check for the model fit. Just start IC. Okay, we are going to execute here, and what we are going to look at now is okay, here you have both models re-estimated, and you have here the value of ISC and BIC. Okay, so you have to compare this value with these. So these are the 2 values of the corresponding models. And when you have these 2 values, you can see that usually, this is what usually happens with an ARIMA model, that 2 do not differ too much. In fact, this is also our case. They do not differ a lot. But actually, you are going to go for the smaller one. Okay? It means that this suggests that it is the more parsimonious model. So the one that best explain the phenomenon we are going to focus on, and but using the lower number of legs. So this is the best model that you want to use in your research. So in our case, we decided to go for the first one, that, as we already seen in the previous part, was already, here we have the 2-1 ARIMA model, and here the 1-1 ARIMA model. So it was already suggested, we already have an insight that it was the best one. So I would go for the ARIMA model 101, okay? So one lag in the autoregressive component and one lag in the moving average component, and this we can say this is the according to our data is the best model to forecast GDP growth in our data set. The ARIMA model, as I said, and the autoregressive or the moving average model per se are a kind of linear model for forecasting. But the other part of this seminar will focus on non-linear models. In particular, we are going to use the threshold autoregressive model, TAR, okay? And here, to use this model, yes, we are going to use a command that actually is not designed in Stata 13, but Hansen, the author that made available both the data set and the ADO file that you should have downloaded already. So made available this ADO file with the code to implement the threshold autoregressive model in Stata. So now you go in File and open the ADO file. We will focus on the threshold regression. So this is the threshold estimation. When you have an ADO file that basically consists of a code to implement a new command that is not part of the existing Stata command, you select everything and then execute. Okay. Now we go back to the do file, and let's see that the command, the very simple command, is threshold reg. So this is the command to the threshold estimation. So the threshold autoregressive model, in contrast to traditional linear model that allow for model change to occur in the time space, actually the TAR model, as I said, uses threshold space to improve linear approximation, and these models are quite popular now in both linear and non-linear model, but especially in non-linear time series. That's the case we are going to see today. So the threshold command, this one, computes estimate and confidence intervals for the model. So as the author of the ADO file, so as Hans had highlighted, simply you have to type this command, then you have to put the dependent variable. Well, if we consider the data set we have and the exercise that the authors, both Durlauf and Johnson and Hansen, have run, I would like to, okay. In their case, the authors want to understand, explain the real GDP growth. Okay, so the dependent variable in their case, and we can use the same, is GDP growth. Then you can put all the independent variables that you want. The original exercise, put log growth and all the others, the initial investment in GDP, population growth, or the variables. Then you have to use this command, Q, and put the threshold. So according clearly with the theory you are going to estimate, with the idea that the model that you are going to estimate, you are assuming that there is a threshold effect. The authors assume that the threshold effect could be both GDP or literacy. Okay? So in the first estimation, they use the GDP threshold, and they also specify for heteroscedasticity. If you execute this command, okay, what variable is not log growth? So I got something log growth. Ah, it's not log growth, it's log GDP. Here, okay. Okay, you can see the first result. Here there is the first result exactly as in the paper actually, so we are just replicating the exercise. Here, if you also see in the results, the results suggest that there could be a second regime. So the idea of applying a threshold regression models is that there are at least two regimes, so more than one, in which there are different threshold effects. So in the first one we have estimated there is a GDP threshold effect, and it is about a certain number of countries that has a GDP lower than this value. We didn't put exactly all the independent variable that the original paper put, so if we put also school sample, we have a different suggestion. Okay, so here you can see, and you can see even in the data, that using all the independent variable, the second regime could be the one in which countries have at least a GDP higher than 863. This is the indication that you have to use to split the sample now. So the threshold estimation now gives you a suggestion to focus on a second regime. So here what we are going to do is to drop GDP lower than 863. And this is the second split. It should be this one. Well, it's not. GDP. It does not recognize the lower command. That's very strange. It's strange, but this should be. Okay, I don't know what's the problem now, but this command is a standard one, so GDP lower than 363 should allow us to drop the countries that have a higher GDP than $863, and actually if, right, so let's drop if, thanks, okay. So I forgot to use this command, which is the condition that we are going to tell Stata to use. So drop a country if the GDP is lower than this value. The actual number of countries that in this data set have the GDP lower than this value is about 18, and the total number of countries was 96. So we have a second part of a second split, a second sample split on which we can focus, and we can estimate as suggested by the author. So following exactly their idea, we can estimate a second threshold regression in which the threshold that we want to test is literacy. So we are going to see if there is an effect, a threshold effect for these variables. And here you can see that the second sample, okay, has this shape, this trend. Here, well, you can see the lowest value. You could also imagine to split this sample where there is a literacy effect on the GDP growth in two. But actually, we already know from the paper, from the author's suggestion, that then there is no effect, so it's not extremely significant to split, to further split this second sample in two. So here you have, as I said, the threshold command that you can use to estimate the threshold effect. Stata 13, as I said, without the audio file does not recognize this command, but there are also other software that are very widely used for a nonlinear model, even for the threshold autoregressive model. For example, R, SAS, they already have implemented a command for that. If you want to do that in Stata, you have to use this procedure. So the threshold command, the dependent variable, the independent variable, the threshold you want to specify before and after the sample split. So in the first regime and in the second one, here we can say first regime and second, and specify for heteroscedasticity. And perfect, we are perfectly in time, I think. So that's everything that I was going to cover for today. So I hope you enjoy. I hope you will use this do file. And if you have any question, please ask.
Brilliant. Thank you very much, Marianna. So if you've got any questions, if you can just write them into the question box on the right-hand side of the panel, and then Marianna can help you with them. So we'll just wait a few moments to see sort of what questions people have got. Okay, so we've got a question asking, why do you set H(1) in threshold regression?
Okay, this is okay. Here, again, I'm following as the suggestion of the author of Hansen. So you can put both 0 and 1. When you put 0, you are imposing homoscedasticity. When you put 1 is to use white correction for heteroscedasticity. So here we followed his example, and we, even because if you read the paper, you can see that the authors already checked for all these effects. But according to your model, clearly you decided to set 0 or 1.
Okay, and can you give an economic intuition of any of the two regimes that you've used?
Yes. In the majority of cases, so in the biggest sample, because here we drop just, as I said, 18 countries from total sample, which consists of 96. The threshold effect is, there is a threshold effect literacy, so we can argue that the level of literacy actually affect the real GDP growth, as the paper actually, the original one by Durlaf and Johnson already explained.
Okay, thank you. And are there any? Is there any requirement for sample size?
Sample size. Requirement for sample size. What do you mean in this case? For example, the number of country.
I'm unsure. Perhaps if the person asking that could just come back with a little more information, and we'll move on to the next question and come back to it.
Okay.
So in the linear model, how do we choose the model fit?
Okay, so we go back here. So we checked for AIS and BIS for model fit here. Okay, we executed. Okay, and here, okay, clearly, here I'm going to execute another one. But anyway, you have to look, as I said, at the value of here, AIC and BIC of the two models. The two models that always they are very, very similar. So the difference, I mean, it's not a huge one, and you have to go for the smallest value, because as I say, the smallest values indicate that that one is the most parsimonious model, so the one that better explain the phenomenon.
Okay, so just going back to that question on the requirement for sample size, the question is just saying this data has only got 96 observations, so could it be done on more or less?
Oh, clearly, it really depends on what you are going to test, actually. So consider that this is a data set used many years ago, so the time series is about range between, as I said, 1960 and 1983, so it covers 20 years period, but it was done a lot of time ago, so now we usually have even the opportunity to collect more data. But it really is up to you in terms of the research, so the principle is that the sample should be as much representative as possible. And Stata, if this might be interested, actually Stata 13 and even Stata 14, they can handle huge data sets, so a lot of variables and a lot of observations.
Okay, thank you. And can you give an example using the threshold test.ADO?
Yeah, okay. So if otherwise you want to do the threshold test, okay, I'll put here. So we're going to test for threshold. Okay, as before, you have to import the ADO file because again, this command is not already in Stata. You select everything and then you're going to execute. Now, Stata is going to recognize the command, which is threshold test, then dependent and independent variable. For example, we can copy and paste the dependent and the independent variable as we said before. And then there are other commands that you have to add. So you put Q, again the threshold, for example GDP. Then you have to specify to use this command trim per, and here you specify the percentage of the sample that you want to focus on. So let's say 0.15, and then using the command rep, you're going to specify the number of bootstrap. Here I used the same as in the exercise and in the paper. I mean, the threshold test, this should be not capital. There is threshold test, should be this one. Yes, it is going to execute now. Okay, and here you have the confidence interval, the graph that you can copy and paste, and here the results of the test. And then after you have done the test for both variables in this case, or for any threshold variables that you have set, you do the threshold estimation, the actual threshold estimation. So in terms of, in steps, you have to do the test first and then the estimation.
Brilliant, thank you. So we'll just wait a few moments to see if there's any other questions. And are there any benefits for using this software for doing this kind of linear and non-linear forecasting over other softwares?
Well, the benefit of Stata for any kind of models, I think it is pretty intuitive. So once you have learned the command, and for any kind of exercise or any kind of estimation you are interested, it is pretty easy to find the command online. You can download the Stata manual, and it is a bit about trial and errors. So you have to learn a bit the name of the command, but you can also use, for example, here, if you don't want to type in the ADU file, you can go, for example, here in statistics and select time series, and here you see the ARIMA models. So what I've done in the do file, actually you can do even using the interface. Now is a bit stuck, but it's not about Stata, it's about my computer. It's about, okay, my computer that is a bit low. Here, for example, you have time setting, okay, and here Stata immediately recognize the time variable, and just you have to specify, for example, as we have done in the do file, that these data are quarterly and so on and so on. But apart of this, I think Stata is pretty intuitive, while R, for example, is less intuitive. So it really depends on what you are going to do, what you want to do.
Thank you. So we've got another question. How do we then forecast outside of our time interval?
What do you mean? How do we forecast outside the I didn't understand the question probably. The time interval, the confidence interval, do you mean? If you can answer. Date. Outside the date interval, so outside our range, I'm not sure about this question actually. Into the future. Well, the future is about the part, the ARIMA model that we have tested. So, for example, well, let me think about it, because I'm not sure. There is a forecast command. I don't know actually, so I'm not sure about this answer. If you want to email me, I will have a look at this. Can you enter the result of the ARIMA while list? Please, what that it means to us. Okay, let's go back to the result of the ARIMA list.
Okay, while you're doing that, I'll just repeat the question.
Okay, yes, because
so the question was, can you interpret the results of the ARIMA Y list, ARIMA 101, and what does this tell us?
Okay, here, for example, this is the ARIMA with the one lag on the autoregressive and one lag on the moving average. The result is telling that this model is significant, so both lags are significant. So it means that this is the right number of lags that you have to use to forecast the GDP growth, because this is the point when forecasting a time series, you have to decide how many lags you want to use, and but as much lags as you use, less parsimonious is your model. So here is going to tell you that this is a reasonable number of lags to use to forecast your GDP growth.
Okay. So we've got a question here. What about assessing in sample forecasting first?
What about assessing in sample forecasting? I'm not sure about the question. Again, do you mind to write me maybe an email, even with an example? I can think about that probably, and I will get back to you.
Okay, so if we look at this one, why is the L1 after the MA, why does that come up negative? In the, I think that was in the ARIMA Y list.
Yes, here. Well, it can be negative, so it's not a problem.
So if you use the predict, do you have the predicted fitted values?
Yes, that's at least my suggestion. That's it?
Yeah, I think so. We'll just see if there's any more questions coming in.
Okay, there is a question that probably, okay, someone says the session is not about forecasting, but is about fitting model, linear or not. Yes. So actually this was the aim of the webinar as I designed it. So and usually RIMA, autoregressive and moving average model are model for forecasting. So they usually are the first step in using a time series. But if you want to forecast later on, and there is a simple command which is exactly forecast, you can go ahead, or maybe we can think about another webinar more focused on this aspect. Clearly, again, you can email me even for this aspect if you prefer. The last question is related to my previous one, forecasting to future date. The last question about L1. Okay, the forecast command. Okay, sorry. Yes, this is a very simple command, the forecast command, and then you will put the Y list and everything you want to put. Yes, sorry, I didn't understand before.
Okay, brilliant. So I think we'll probably leave it there for the moment. Thank you for all your questions. Sorry if there was some confusion over what was going to be covered today.
Just I want just to add, this is the part that you can use here about exactly forecasting if you are not using the command forecast itself.
Brilliant. Okay, so thank you very much for your questions, and thank you very much to Marianna for hosting the webinar today. Thanks.
Thank you.